Okay, so P3 part 4, trinomials with binomial factoring. So remember this standard form of an equation, x squared plus bx plus c, and we have to factor that out. So you are going to start doing a lot of factoring. Okay, factoring or foiling, we're going to do that. So let's go with this. Let's try this. Factor x squared minus 7x plus 12. Okay, I need to factor this. Is there anything in common that I can take out of there to start with? There's an x in all three of those?
Nope.
Nope. So there's nothing I can take out, right? So that's where I'm going to basically unfoil it. Okay, I know that my leading is x squared, so I have an x here and an x here. It makes it a little easier. Then I ask myself, what multiplies to give me 12 but adds to give me negative 7?
3 and 4.
3 and 4. Okay, good. 3 and 4. 3 and 4 will get me to 7 and to 12. What do these signs need to be? Both need to be negative. And here is why. Negative 3x and negative 4x gives me negative 7x, but negative 3 times negative 4 gives me a positive 12. So both have to be negative. So when I solve that, I get x minus 3, x minus 4, okay? You can always check it, okay, by refoiling it out to see if it comes to the same thing. What about, let's see here. What if I try x squared plus x minus 6? Would that factor out? Does that factor out? How does it factor out if it does?
It doesn't factor, I usually use.
6 has multiples of 6 and 1 and what? What else goes into 6? 2 and 3. Can 2 and 3 add to give you positive x and multiply to give you negative x, negative 6?
Sure.
Okay. What has to be positive and what has to be negative? 3 has to be positive because this number becomes positive, so the larger one's positive, and that has to be negative. So that's how you would factor that. Everything we do is going to be a factorization. Let's factor a couple with leading coefficients that are not 1. How about 2x squared minus 5x plus 3? 2x squared minus 5x plus 3. How do I factor that out?
Well, close your book. Take notes.
How do I factor out 2x squared plus minus 5x plus 3?
What about 2 and 5? Do you go to x?
No, I need to, okay, so what I have to do is I know I have a 2x, so I'm going to have an x here and an x here because that gives me 2x squared when I multiply it together. Now I look at 3. What are the factors of 3?
3 and 1.
3 and 1. But I need to be able to multiply 3 or multiply 1 by 2 somehow to get me negative 5. So I need to multiply those together to get me to negative 5. But I need a positive 3. So if I do 3 and 1, which I have to do, let's say I put a 3 here and a 1 here. 2x times x gives me 2x squared, right?
Yeah.
2x times 1 gives me 2x. 3x, and then I get 3. So do these need to be negatives or positives? If the middle is negative, but the outside is positive, I need negatives. Because these add together, whereas this gets multiplied together, and when I multiply two negatives, I get a positive. So when I refoil it to check it, I end up getting what I started with. Okay, leading coefficients can be tricky. 12x squared plus 7x plus 1. 12x squared plus 7x plus 1. Okay. This is nice because my factor over here is just 1, so I know a 1 and a 1 goes there. So how can 12 break down to add to give me 7? This is an easier way of dealing with that leading coefficient.
6, 4, 2, no.
What'd you say?
3 and 4.
3 and 4? Okay, 3 and 4. So one is 3x, one is 4x, and are they positive, negatives? What's going on? Yeah, because everything is positive in here, then I have positives here. Okay? We are going to factor like crazy. Okay, the other type of factoring we need to talk about is factoring by grouping. Do you guys remember factoring by grouping?
Sure, when you say something.
Yes. It's when I have more than 3, okay, I'm going to factor by grouping. So let's say you have x cubed minus 2x squared, okay, minus 3x plus 6. This is a case where I would try to factor by grouping. First of all, I want to look and see if there's anything I can take out of all of this. Can anything come out of all of that?
Yes.
Yes? What? Nothing can. So then I'm just going to start by grouping this segment together and this segment together. I want to take out stuff from both of those segments so that the segments remaining have the same parts. So what can I take out of here?
I'm sure you can take an X.
I can take 2 of them, yes. I can take an x squared out so that I have x minus 2. What can I take out of here?
3.
Okay, let's take out the negative, because remember, I want this inside to look like this inside. So negative 3, and that leaves me with x minus 2. Now, these two come together. X squared minus 3 comes together. Okay? These come together to make this. These become 1. Okay, because there's a pair, they're now 1. And that is my factorization, because I can't factor either of those further. Well, what happened is we're factoring by grouping.
Oh, you just put the things together.
Mm-hmm. Yes, sir.
That's a lot of things.
Use factoring by grouping to factor a trinomial. Let's look at this. What about 2x squared plus 5x minus 3? 2x squared plus 5x minus 3, and I want to factor by grouping. How can I factor by grouping that? That sounds kind of weird to me, right? Because it's a trinomial. Okay, 2x squared plus 5x minus 3. In the trinomial 2x squared plus 5x minus 3, okay, a equals 2. Stop talking. A equals 2 and c is negative 3, because over here we talked about how you have a, b, c. So we know that a equals 2 in this, and we know that c, my constant, is negative 3. Okay? Which implies that the product a times c is negative 6. So if I multiplied a times c together, you would get negative 6, because it would be 2 times negative 3. Okay? Now, because negative 6 factors as 6 times negative 1 and 6 minus 1 equals 5, which is b, you can rewrite the middle term as 5x. So I can rewrite this middle term as 5x, okay, equals 6x minus x. Because this would factor out as, if I factored it, it would be 6x minus x, because I could factor this portion there. So I can plug this in for that, so that I get 2x squared plus, okay, plus 6x minus x minus 3. Now I can group. When I group, what do I pull out of here? A 2x. I'm left with x plus 3. What do I pull out of here?
Negative.
Negative 1, good. And I get x plus 3. Now, these parts are the same. That's what we wanted. So I have 2x minus 1 comes together here. And then these come together to give me x plus 3. There's my factoring by grouping. Okay? I won't make you factor these by grouping if you can do it this way, like we did over here. Good. Okay. Guidelines for factoring polynomials. There are guidelines for factoring polynomials. There are 4 that we need to take a look at. Okay, guidelines for factoring polynomials. 1 is factor out any common factors. That's step 1. Factor out any common factors using the distributive property. Number 2, you are factor according to one of the special polynomial forms. So check to see if it's one of the special forms we talked about. Okay, factor according to one of the special polynomial forms. Number 3, factor as ax squared plus bx plus c. In standard form is what it's saying. Factor in standard form. And that comes out to always equal something like mx plus r times mnx plus s. And then step 4, and these are all things that we've talked about, factor by grouping. That's always my last option, is factoring by grouping. So when you are factoring, first thing first, you always look to take out the common information. Then you check to see, hey, could it save me time? Is it one of our special things, our special polynomial forms? Then if not, you have to straight up factor like we did here. And then if that's not possible, you have to group. Let's do homework.
Hey, Josh,